Hello to everyone. My name is JC3. I am an assistant professor in the Civil Engineering Department in the Aristotle University of Thessaloniki. Today I will be presenting to you the results of a diploma thesis, which I had the pleasure to supervise. The two students were Efthymios Klinis and Athanasios Kanelakis. These were the two students that implemented their diploma thesis, and there's one other author. His name is Theodoros Mastouras. He's a PhD. He has taken his PhD on applied informatics, and he's the person responsible for introducing us to the tool that we used in the current study. So this paper mainly applies the FUN tool in order to predict, to estimate, to calculate the final duration of a number of highway construction projects implemented in Greece. In Greece, many problems arise and create deviations regarding the scheduling of the projects, and this has often associated with law disputes during the construction, project financing, archaeological findings. I could say this is one great parameter. Environmental issues, extremely important, and last but not least, private land acquisition procedures, which can take a lot of time. So this is a list. It's not an extensive one, and I may have forgotten some of the scientists that have applied neural networks to the prediction of the final construction project schedule. Now, as far as the data that we have used is concerned, these are all the parameters that we did manage to find for each project: the length of the highway project, the number of lanes, the number of associated technical projects, the existence or number of bridges, existence or number of tunnels, height of slopes, the region where the project was implemented, the contract signing date, the initial project budget, or the initial cost estimated by the awarding authority of the project, the initial contractual cost, the initial project schedule, and the actual project schedule. So what we did basically is gather all this information. We needed to be able to identify the most critical parameters that are effectively change or deviate the construction schedule. So we did a literature review, and then we focused on the Greek reality, and we just tried to synthesize all this information in order to make a final list of these parameters. But to be honest, many times you can produce a list, but in order to effectively implement this list, you need to have the available data. So sometimes it gets down to the data that is available for you, to use. So we then collected data for 37 projects. We applied the FUN tool, and we just split the projects, a number of two projects, some for the FUN tool to be trained and some for test use. And we made many variations regarding the artificial neural network structure, the training algorithms, and the ratio of the training data to testing data. And finally, we're presenting some of the most promising findings. Regarding the sample, the projects are 37, and they were constructed from the 1990s until the 2010. They come from 4 main regions of Greece. This is Region 1, Eastern Macedonia and Thrace. The second region is Central Macedonia, the third is Western Macedonia, and the fourth is the region of Epirus. So, a bit quickly, I present to you the initial budget per project, the initial duration in days, and the deviation from the initial duration per project. Now, we did use 37 projects to train and test the artificial neural network. We had to identify the most the factors that decisively influence the actual completion time, and mainly we relied on the availability of data in order to perform the analysis with the artificial neural network. Now, we made a lot of trials, and these trials with the artificial neural network, the FAN tool, focused on variations of the structure of the neural network, the different ratios between training and testing data, and alternative approaches regarding the optimum functions for training the network. So the most promising trials were selected, and these were 3 in number. The first one was a network with an input level by 15 neurons, and the output level contained 1, and there was also a hidden layer with 7 neurons. So 25 projects were used as data for training and 12 sets for testing, and some properties used in the first trial included the FAN train ARP probe for as training algorithm, the FAN Elliott as optimal activation function of the hidden level, and the FAN signal symmetric stepwise as the optimal output level activation function. So these are the results of the first trial. The orange line is the actual duration of the project, and the blue line is what we have calculated using the FAN tool. Now, the same thing has been repeated 2 other times for the second and the third trial. So, in the second test, the structure of the network was kept unchanged, and there was a change in the number of the training and testing data. So, we used 29 projects for training the artificial neural network, and 8 projects for testing its efficiency. So in this case, the optimal training algorithm was again FAN trainer probe. The optimal activation function of the hidden level was the FAN Elliott, and the optimal output level activation function was the FAN sigmoid symmetry. So the results in this case were better than the first and the third trial. So this was the most promising trial. Again, the blue line is what we have calculated using the FAN tool, and the orange line is this what was really happening to the project. The third and final attempt using the FAN tool, now we decreased the number of the input variables. So instead of the 15 initial, we used only 6 variables. So these were the initial budget, the length of the highway, the number of lanes, the number of technical projects associated with the road construction, the number of bridges and tunnels. 25 projects were used for training the artificial neural network and 12 projects for controlling it. And as far as the structure of the neural network, so we have 6 neurons at the input level, same number with the variables used. One was the output, and the hidden layer consisted of only 2 neurons. These were the parameters associated with the third trial: fun, train, and incremental as the optimal train algorithm, fun symmetric for the hidden function, and fun linear p-symmetric as the level activation function. And these are the results of the third trial. This was not a good one. So, as far as the research results are concerned, taking into account the mean squared error for the tests and the mean absolute percentage error from the 3 trials, among a large number of them we had tested in the lab, the second one was the most promising one, which had the smallest deviations. And what we would like to mention is that several of the projects have significant deviations between the calculated and the actual values. A number of successive tests have taken place which focused on altering the structure of the network in order to improve its efficiency. But unfortunately, the test results have slightly improved. Regarding the conclusions of this study, we can say that there is indeed an ability to predict. The results are satisfactory, this can be said. There is a large number of qualitative and quantitative variables that affect the project duration. One of the critical parameters that should be taken into account in a future endeavor regarding this field is the human capital, and more specifically the project manager's experience. And I should mention also that the results, the outcome of each method or tool largely depends on the reliability of the input data. So this is also something to be examined thoroughly. Now, regarding the fun tool, which is the tool that we have used in this study, it's a very easy and simple to use software. It has successfully automated a lot of processes, and deeper knowledge into the artificial neural networks could lead in an improvement in several aspects of the fun tool. So, regarding the future work and some suggestions, the first one, I would not be so genuine. A greater data sample is definitely needed. We can use neural networks, but it is important that we have created a reliable, extended project databases. We also think that we must use statistical analysis along with neural networks, especially in the part of screening the data that is available. Regarding Greece, archaeological findings, private land acquisition, weather conditions, and environmental also permits are some of the critical factors that do affect largely the projects, especially highway construction projects. Then we can apply neural networks on a more detailed level regarding work packages, and we can also apply different programs regarding neural networks and see and compare the results that are produced. So I would like to thank you so much for your attention, and I would also like to acknowledge to provide acknowledgement this one. This is my 5-year-old son. He was kind enough to permit me to complete this presentation, and I would be glad to answer to any questions that you might have. Thank you.